Hello and welcome back to 6.2 Notes Day 2. We're going to be graphing exponential functions. Exponential functions look like something like this equation right here. Your A is going to be your vertical stretch. Your H is your left and your right shift. And your K is your up and your down shift. And then your base here is really important. It's your B value. That's going to be what determines your table. So as a quick refresher, your table of values is -1, 0, and 1 for your x values. 1 over b, 1, and b being your base for your y values. Upon the x values, you're always going to add h. Upon your y values, you're always going to multiply by a and add k. And then for the rest of that, we're going to take a look at the graphs of those to identify your domain, your range, and all of that other stuff. Okay, so let's go ahead and take a look at example 1 here. So the first thing to note is your base here is 2, which means there's nothing out in front for your a value, so your a value here is 1. It's not being stretched or flipped or anything. Your h is your exponent here, except you're going to do the opposite of what's there, so you're going to actually be moving left 3. And your k is whatever's at the end here. It is -5. Okay, so once you can identify all of these, what we're going to do is we're going to create our table of values, -1, 0, and 1, and 1 over our base, which is 2, 1, and your base, which is 2. Then, every single time with your x values, you're always going to add h. In this case, since we're moving left 3, we are going to subtract 3 from each of these. So -1 minus 3 is -4. 0 minus 3 is -3. And 1 minus 3 is -2. For your y values, you're always going to multiply by a and then add k after that. So we're going to multiply all of these by 1, and then after that, we're going to subtract 5. So 1 times 1/2 is 1/2, minus 5 is -4 and 1/2. 1 times 1 is 1, minus 5 is -4. 2 times 1 is 2, minus 5 is -3. So then we can graph all of our new table of values here, the x comma y. So -4, -4.5, -3, -4, and -2, -3. And we want to make it into this nice slide, but the problem is we can't just kind of go whoop and say that's our graph. Instead, we have to have an asymptote drawn in there. Now your asymptote, as a reminder from yesterday, is always going to be y equals your k value. So our k value here was -5. So our asymptote is going to be y equals -5. And if we actually draw that horizontal line on our graph here, that's going to help us graph our exponential function a little bit more nicely. So on your graph, you should see a slide, and you also should see this dotted line here showing your asymptote. Now our base here was 2, so our graph here represents exponential growth because from left to right it's going up. Your domain is -infinity to +infinity. Your range from low to high starts at -5 and goes up for forever to infinity. And -5 has a parenthesis because we will never actually get to -5. Let's try another one. This one is going to have a base that's a fraction, so it's going to be kind of weird when we make our table of values. So first identify that 1 over 3 is your base. Next, your a value is out in front, which is 3. Your h value is 0 because there's nothing being added or subtracted up there with the x. The -2 is your k value, so it is moving down 2. So your x values are -1, 0, and 1. Your y values are going to be a little bit more tricky to figure out. So it's 1 over your base, 1, and your base. Now our base here is 1/3, so we can just go ahead and plop that down for our last one because that's our base. We can also write down 1. The tricky part is 1 over your base. For this one, it's 1 over 1/3. Now, we don't like seeing 1 divided by 1/3. We don't like having a fraction within a fraction. So what we can do is we can multiply by the reciprocal. And what happens is if you take your base, if your base is a fraction, and you flip it, that's what 1 over your base is going to do. So my y value here is actually going to be a 3. Imagine again, when we do 1 over your base, take your base and you flip it around. Flip it over on top of itself. 3 over 1. That's what the reciprocal of your base does. Now, for your x values, you're going to add your h value, which in this case is 0. So we're not moving left and right at all. Your y values are always times a plus k. So for each of these, we're going to multiply by 3 and then subtract 2. So times 3 minus 2. So 3 times 3 is 9, minus 2 is 7. 1 times 3 is 3, minus 2 is 1. 1/3 times 3 is 1, minus 2 is -1. So now we have our new table of values. We can graph -1, 7, 0, 1, and 1, -1. Before we actually graph it, we're going to write our asymptote down. It is y equals our k value, which is -2 in this case. And we can put a horizontal line down at -2 here. Which means now we can connect this and make it look like our nice exponential function. This graph is going down from left to right. It is decreasing, making an exponential decay. Also, your base was a fraction less than 1, so that's why it's decay. Your domain is -infinity to +infinity, and your range from low to high starts down at -2 and goes up for forever. So let's go ahead and take a look at another one. You have an a value of -3, an h value of +4, a k value of +2, and your base here is 2/5. So we're going to do -1, 0, and 1 for our x values. We're supposed to do 1 over b, 1, and b for our y values. So I'm going to write down 1, and I'm going to write down my base of 2/5. To figure out 1 over b, my base was 2/5, so what I'm going to do is I'm going to flip that around. That's going to be 5/2 for my first one. So for your x values, you're always going to add h. In this case, we're going to move them all right 4. So we're going to add 4. Ooh, that's a 5. For your y values, you're going to multiply by a and then add k. So for each of these, you're going to multiply by -3 and then add 2. So if you want to use your knowledge of fractions, that's awesome. If you'd like to use your calculator, that's fine too. But 5 over 2 times -3 is -15. And if you add 2 to that, you get -11/2. 1 times -3 plus 2 is -1. And 2/5 times -3 plus 2 is 4/5. If you'd rather use decimals, so -5.5 and 0.8, that is totally fine, because honestly that helps us graph a little bit nicer. 3, -5.5 is a little bit easier to think about. 4, -1, and 5, 0.8. Now I need a little bit of help with this one with my graph because it's kind of looking different than the ones have in the past. My asymptote here is y equals 2. So I'm going to use that as kind of a boundary. So what's happening is this one got flipped over and it's now going up like this. So the weird part about this is my base here was 2/5. So because it's a fraction less than 1, I would have said decay. But if you look at your graph is actually going up from left to right. So it's not decreasing, it's going up. There's a contradiction there. And so what happens here is if your a value is negative, which it is in this case, we had a -3, you get a contradiction between your graph and what your equation says. So you're going to write neither growth nor decay when that happens. So anytime your a value is negative, you're going to write neither growth nor decay. Okay, so now looking at this, your domain is -infinity to +infinity. Your range, this one starts down for forever and then has a high value of 2, so it's -infinity to 2. Okay, now that we've gotten the hang of graphing exponential functions, we're going to go ahead and we're going to write exponential functions. Now, when we write exponential functions, we're going to focus in on just an a and a b value. We're not going to do an h and a k. And this kind of narrows things down a lot. Your a value here is your initial amount. This is always going to line up with your y-intercept. Okay, so if on a table or a graph, if you see 0, some number, that number is your a value. Now, to find your b value, that is your constant ratio. That is, how do you get from one number to the next? What are you multiplying by in order to get from one number to the next? So let's look at this first table here. So I look at this, and when I see 0, something, this something is always your a value, which means you can always immediately write y equals 4 for this case. Now your b value is always, how do you get from your one y value to your next y value? So if you look at your numbers 4 to 12, 12 to 36, 36 to 108, what's happening each time here is you're multiplying by 3. Whatever that is your b value. So we're going to write a 3 in here for our base, and this is our equation. You can always check your equation by randomly plugging in an x value that's on your table and seeing if you get your y value back out. Let's take a look at the next one. So it's going to be y equals a times b to the x. Your a value always comes from your y-intercept, 0, something. So we're going to use 128 as my a value. Now, for my y values, I'm going from 128 to 64 to 32 to 16. So what's happening here each time is you are dividing by 2. So what we're going to do is, instead of saying dividing by 2, we have to show it as a multiplication problem. This dividing by 2 is the same thing as multiplying by 1/2. So any division problem, you're going to make it into a fraction instead. So let's go ahead and try the next couple, just a sequence of values here. So 0, 3 means that 3 is your a value. Your b value is, how do you get from 3 to 12, then to 48, then to 192? You're focusing in on your y values. You are multiplying by 4. So you're going to use 4 as your base and x as the exponent. And lastly here, you have 2,187 as your a value. To get from one y value to the next, it's kind of harder to see. We can tell it's going to be a division problem, but you might have to look towards the end, or you might have to take and divide some of these numbers on your calculator. Each time you are dividing by 3. So because it's division, you're going to make that into a fraction here, and it's going to be 1/3 as your base. Okay, so that's how you write exponential equations. What we're going to do is we're going to try one more problem here. I'm going to ask you to try this one by pausing the video and trying all of it on your own, and then unpause the video and come back here to see if you were right. So pause the video right now and try it on your own. Okay, so let's take a look. 2, 3, and 4 for your x values, -10, -4, and -2.5 for your y values. You can see y equals -2. You can see it's neither growth nor decay in your domain and your range there. Thank you very much for listening. I hope this helped. Have a good day.